Hey everyone, hope that you're having a great day. Today we're going to talk about 10.3. It's about the binomial theorem. This is a pretty important section, so I'm glad that we're able to have a video for it so you can go back and watch some of the examples again, because some of them can get kind of tricky. So let's go ahead and get started. And we're going to start with a little warm-up here. So if you want to try this warm-up, you should be able to expand these things without using anything too special. And I just want you to expand it and take a look at what the coefficients are. So for both of these, you'll have to use the coefficients. So if you want to pause the video and try expanding these on your own, you should be able to use FOIL for the first one and then kind of a little bit more for the second one. But if you want to give it a shot, go ahead. You can pause the video and try it, and then we'll come back and try them together. All right, let's go ahead and try these. So I got separate slides for these, I think. So the first one, x plus y squared. So remember what that means. We can't just square x and y, right? That is like the big mistake that we're not allowed to do. It's a big no-no. So x plus y squared, that just means x plus y times x plus y again. So some of you call this FOIL, some of you call it repeated distribution, doesn't really matter. X times x is x squared. X times y is xy. Y times x, I'm going to write that as xy again. And then the last terms give me plus y squared. So altogether, that gives me x squared plus 2xy plus y squared. And I asked about what the coefficients are, so let's take a look at those coefficients. Looks like the coefficients are 1, 2, and 1, right? So just looking for the numbers in front here. Remember, there's a 1 hiding here. There's a 2 right here. Then there's a 1 hiding right in front of that y squared. So 1, 2, and 1 are those coefficients. So I'm going to remember this here, x squared plus 2xy plus y squared. And that's going to help me for the next part. So now we're going to do x plus y cubed. So that's x plus y times x plus y again times x plus y one more time. Now, we've already gotten x plus y times x plus y. That's why I said we wanted to use that from the last part. That's x squared plus 2xy plus y squared. And now we're trying to multiply it by one more x plus y. So I'm going to kind of use an idea like FOIL here, but I'm going to multiply everything by everything else. So if I do the first terms, that gives me x cubed. And then the first term times the second term over here gives me x squared y. Now let's take a look at this. 2xy times x. That gives me 2x squared y. Then that guy times the last term, that would be 2xy squared. And then looking at the y squared here, if I do y squared times x, that gives me xy squared. And then y squared times y gives me a y cubed. Now if we gather our like terms here, it looks like we just have 1x cubed. And then we have 1x squared y and 2 more, so we have 3x squared y. Got those from these terms right here. And then it looks like we have 2xy squared and 1 more, so we have 3xy squared. That's from these guys right here. And then we have a y cubed at the end. So again, I'm asking you to look at the coefficients. There must be some kind of a pattern or something weird happening with these coefficients. So look at the coefficients here. It looks like it's 1, 3, 3, 1. Now, so our first one, we had 1, 2, 1. Then the next one here, we had 1, 3, 3, 1. And let's see if there's some kind of a pattern coming out. So do we have any guesses for x plus y to the 4th or x plus y to the 5th? Well, looking at this pattern, 1, 2, 1, and then 1, 3, 3, 1. This looks like a lot like something we saw the other day with combinations. Check this out. If we look at Pascal's triangle, 1, 2, 1 were our coefficients for the first guy, and then 1, 3, 3, 1 were the coefficients for the cube. So the 4th power, maybe our coefficients are going to be 1, 4, 6, 4, 1. So if that is indeed our hypothesis, then we should try it out. So we have x to the 4th, so that should be a coefficient of 1 in front. And then our next one, so if we do x cubed y, so basically we're going to go down in degree with our x's and come up with the y's, which is pretty much what we did over here, right? Check it out. So we have x cubed, and we have x squared y, xy squared, and y cubed. So the x goes 3, 2, 1, and there's no x at all. The y starts with none at all, then 1, 2, 3. So if we follow that pattern, we should be able to figure this out. So we have x to the 4th, and we have, so x is going 4, 3, we'll do the coefficients later. So then we'll have 2, and then we'll have y squared, because y is coming up, 0, 1, 2. Next one will be xy cubed. And the last one will just be y to the fourth. So let's see if we put in our coefficients, if it works out. So 1 on the first one, then 5 for the second one, then 10, nope, sorry, I'm on 4 here. So we have x to the fourth, and we have 4x cubed y, and then should be 6x squared y squared, and then 4, and then 1 at the end. So we don't really have to put the 1 there. So this is x plus y to the fourth. Now we could have expanded that out like using FOIL, but this binomial theorem just tells us we can really just use the row of the triangle, which is pretty cool. So x plus y to the fifth. The first one's going to be x to the fifth power. Then we'll have some kind of coefficient in front of x to the fourth y. Then some kind of coefficient in front of x to the third y squared. And then we'll have something in front of x squared y cubed. And then xy to the fourth, and the last one will just be y to the fifth, and that should have a 1 in front of it. So let's put in our coefficients. We have 5, 10, 10, 5, and then 1. So, one more thing to notice here. So we notice the x goes down. 5, 4, 3, 2, 1, 0. Y came up. 0, 1, 2, 3, 4, 5. What do you notice about the two exponents together? Here the exponent is just 5. Here it's 4, and then really there's a 1 here, right, hiding? Those add up to 5. 3 and 2 add up to 5. 2 and 3 add up to 5. 4, and really there's a 1 right here, right? And there's a 5 here at the end. So the exponents always add to the original exponent that we had. I'm going to call it n. Because today what we're really going to focus on is expanding out x plus y to the nth power. So here we had 4, and we notice that 4, and then 3 and 1 are 4, 2 and 2 are 4, 3 and 1 are 4, and then here we had 5 was our n value, and so everything added up to 5. And this is going to be a common recurring theme. So using the triangle and this idea of making sure that our exponents add up to the right number is how we're going to use this binomial theorem. So let's talk about what this binomial theorem is. So if we have x plus y to the n, we know that that means x plus y times x plus y. And we're going to have a whole bunch of these, right? How many are we going to have? Well, we should have n of them. Right? Because if you're doing x plus y to the nth power, we should be multiplying x plus y by itself n times. So we're multiplying it over and over again, and we should have a total of n terms multiplying by themselves. Now, the reason that Pascal's triangle comes into this, and I think I might have it here. Nope, not yet. So the reason that Pascal's triangle comes into this is because when we look at the terms, so you're always going to have x to the n. That'll be your first term. Because you have n of these, so x times x times x times x times x, all of them together. There is one way to pick all of the x's. Right? There's one way to pick all of the x's. But now if we think about how many ways are there to choose n minus 1 of the x's. So for example, let's say that we had x plus y. Let's think about it, what we had to the fourth. Okay, so we expand that out, x plus y, x plus y, x plus y, and x plus y. Now, without thinking too hard about this, to get x to the fourth, there's only one way to do that. You take x from each one of them. So basically, each one of these things I have to think about as a separate item, and I want to pick either the x or the y. So now I want to know how can I get 3 x's and 1 y. So from each one of these I have to choose something, but how can I get 3 x's and 1 y? Well, I'm leaving basically one of the x's out. So I could choose the first 3 and then leave the last one out. Or I could choose the first 2 and the last one and leave the second to last one out. Or I could choose the first one and the last 2 and leave the second one out. Or I could leave the first one out. Any way you do it, there are 4 choices. So that's why that 4 came in there. And hey, that is exactly 4 options, and I'm choosing 3 of them. Because I want to know which 3 am I picking for the x. Over here, this was 4, and I chose all 4 of them for the x. The next one, well, I want x squared, y squared. So I'm going to say, which 2 am I picking for the x? Well, it could be the first 2, right? It could be the first and the third. It could be the first and the last. It could be the second and the third. It could be the second and the last. or it could be the last 2. There are 6 options to do that, and that is exactly 4 choose 2, because out of the 4, I'm saying which 2 do I want the x's to come from. That's why it's 6. So then the next one, now I have x, y cubed. I only want to choose 1 for the x. How many choices do I have? I have 4 choices. 4 choose 1. And then the last one, I want y to the 4th. I don't want to choose any x's, so I don't choose any of them, and 4 choose 0 is exactly 1. So really, this is what you do when you are foiling, or when you're multiplying multiple things by themselves. So when you have this x plus y, x plus y, x plus y, you're saying, which ones do I want the x's to come from? Which ones do I want the y to come from? And you have to choose one from each one of them. So that's why you end up with this thing from Pascal's triangle. And if it's n, then the coefficient, so the next one, so this is n choose n. I want all of the x's. Then it would be n choose n minus 1, x to the n minus 1, and then I'm going to need 1 y. Then the next one's going to be n choose, this time I want n minus 2, so it'll be x to the n minus 2, and I'm going to get 2 y's. So notice the exponents are always going to add up to n. First I start with n, then n minus 1 and 1 make n minus 2 and 2 make n, and this is going to keep adding over and over and over until I get to the n. So I'll have n choose 2, x squared, and now y will be all the way up to n minus 2. And then it'll be n choose 1, x to the first, and then y to the n minus 1. Then the last one will be n choose 0, because I don't want any x's, and then it'll just be y to the nth power. So now, some people tend to ask, well, okay, so you're choosing the x's. What if you wanted to choose the y's? This is where the beauty of Pascal's triangle comes into play. We have this symmetry where the first term and the last term are the same, and you notice that there's this pattern with the coefficients, right? That same that's in Pascal's triangle. You could talk about choosing the y's instead. That's fine. So start here with n choose 0, and then you have n choose 1, and then you're going to end with n choose n. But either way you do it, you're going to end up with the exact same thing. So what the heck is this actual theorem? So this is the way that they write out the theorem. They say if you're going to take x plus y and take it to the nth power, you're going to just use combinations. So n choose 0, n choose 1, n choose 2, all the way up until you get to n choose n. So in the middle, any of the terms is going to be n choose k, and they're actually doing it the second way I talked about. So they're picking the y's out. So they're doing n choose 0, y to the 0, n choose 1, y to the 1, and they end up with n choose n, y to the nth power. So usually we use, we've been using the parentheses notation. So you could write it like this. The sum from n equals 0 to, k. So from k equals 0 to n of n choose k, like this. And then it would be x to the n minus k, y to the k. So what's happening here is you're going to start with n choose 0, then n choose 1, n choose 2, n choose 3, and the x is going to start up at n, because if k starts at 0, it'll just be x to the nth, and then y will be to the 0. There will be no y at all. So the first term will be x to the n. The next one will be x to the n minus 1 times y to the first. Next one will be x to the n minus 2, y squared, and you're going to keep going all the way to get to x, y to the n minus 1, and then it'll be plus x, sorry, no x at all, just y to the n. And the coefficients are always going to be these combinations, so n choose 0, n choose 1, and it's just going to be following from the row of the Pascal's triangle. So if you have Pascal's triangle written out, I think that's probably the easiest and fastest way to find those coefficients. This would be n choose 2. This last one here would be n choose n minus 1. And this guy would be n choose n, which is always 1. So, cool formula. You have to practice these. You must practice these, because if you don't practice, you're not going to be able to use this formula efficiently. I can guarantee it. So let's try some practice problems. So we're looking for the power of y and the coefficient of the x cubed term in x plus y to the 8th. So we could expand this all the way out, but they're asking just for one term, right? So this is going to start x to the 8th, then there'll be some coefficient in front of x to the 7th y, and then x to the 6th y squared, right? Because these always have to add up to 1, these coefficients, or these, these exponents. So eventually, we're going to get to some term that has an x cubed. So because of that property where the exponents have to sum up to 8, what do you think the y exponent's going to be? Well, it's got to be 5. So that's the first thing they ask for. Oops. That's the first thing they ask for, is what is the power of y? And it's going to be 5. Okay, so that exponent is definitely going to have to be 5. And now they want to know what is the coefficient in front. Well, based on our binomial theorem, we should start at 8 choose 0, and then 8 choose 1, and then 8 choose 2, and it's going to keep going. So it looks like it's following the exponent of the y. So this guy right here should be 8 choose 5. Now you could do 8 choose 3 as well. It's going to give you the exact same number, but it doesn't really matter which one you choose to use. So if we think about the 8th row of Pascal's triangle, I might even have it here. So we go down to 6th row here. I'm going to make the 7th row. Remember, we can just add. So 1, 7, 21, 35, 35 again, and then 21, 7, and 1. We need the 8th row because we're doing the 8th power. So we have 1, 8, 7, and 21 are 28. This is 56, 70, 56 again, and then 28, 8, and 1. So we want 8 choose 5. Remember, this is 8 choose 0, 1, 2, 3, 4, 5. Notice exactly the same as 8 choose 3, either one. So it looks like our coefficient is 56. So that term would be 56 x cubed y to the 5th. So if you want a little bit of extra practice, you could try expanding this all the way out using these coefficients. But all we were asked to find is the coefficient in front of the x cubed term, here it is, and the power of y, which is 5. All right, let's move on. So here, we're asked to find the coefficient of x to the 4th y squared in x plus y to the 6th. So this again, remember we're going to have x to the 6th, then we'll have x to the 5th y, x to the 4th y squared, x cubed, x squared y to the 4th, x y to the 5th, and then y to the 6th. And the coefficients are just going to be coming directly from Pascal's triangle. So let's go back to our Pascal's triangle and look at the 6th row. 6th row looks like 1, 6, 15, 20. So 1, 6, 15, oh, let's write that a little bit better. So it's going to be 1, 6, 15, 20, 15, 6, 1. So we're looking for the coefficient in front of x to the 4th y squared. So that's going to be 6 choose 2, because it follows the exponent of the y, according to our formula. So 6 choose 2, here is 0, 1, 2. So it's going to be 15. And that's it. So your term would be 15x to the 4th y squared. That'd be right here, so 15. Right, because we have 1, 6, 15, 20, 15, 6, 1. Okay. So that 15x to the 4th y squared is right here. So I wrote out pretty much the whole thing, but all you needed to do was do 6 choose 2, and that's 15. So not a tough problem at all. Okay, now we get into some stuff that's a little bit more fun. And I think I might have the triangle here. Nope, I thought I brought it along with me. I guess I didn't. So the 4th row of Pascal's triangle is 1, 4, 6, 4, 1. The tricky thing here is we have a -2. We also have a 3w. So before I bring those coefficients in, let's just think about what we're going to have for our powers here. So it's going to be 3w to the 4th. And you can see right away why this is trickier, because that 4 is going to go into the 3 and the w. The next one, so I'll leave the coefficient, a little bit of room for the coefficient. It'll be 3w cubed times -2, because this is a plus -2, really. Plus -2. So then the next one is going to be, I'll leave room for the coefficient. It'll be 3w squared times -2 squared. Next one will be -3w. 3w times -2 cubed. And then our last term is just going to be -2 to the 4th. Okay, so key here is that 3w, we have to think about that as an entire thing, like a variable. And we're taking it to the 4th, 3rd, 2nd, 1st, and then not at all. And then -2, same thing. -2 is not there at all. Then it's the 1st, 2nd, 3rd, 4th. Now we just throw in our Pascal's coefficients. So 1 I'm not even going to write, because it's not necessary to write it there. Multiplication doesn't do anything. And then we have 4, and then 6, and then 4 again, and then a 1 right there at the end, which we don't need. So the tricky thing is, we really should bring in these powers and expand these out. So 3 to the 4th, that's 81w to the 4th. Now the next one, 3 cubed is 27. 27 times 4 is 80 plus 28. That's 108. So this is 100. So 4 times 27. So that's 108 times negative 2. So we're probably going to have to do one more step here because I don't want to do all this together. And then it'll be w cubed. The next one, 6 times 9 is 54 times negative 2, and then w squared. Sorry, negative 2 squared is positive 4. So it'll be a 4 there. And then we'll have 4 times 3 is 12 times negative 2 cubed is negative 8w. And the last one, negative 2 to the 4, is just positive 16. So now we have to multiply some of these negative 2's here. So we have 81w to the 4th. 108 times negative 2 is going to be minus 216 w cubed. Then we have 54 times 4. That's, let's see, 216. So we got plus 216. Yeah, it's the same as we had over here. So 216 w squared. And then 12 times negative 8, that's negative 80 minus 16 is negative 96w. And then plus 16. So I do expect you to be able to do this. There's a little bit of algebra involved, and you have to do those powers of the numbers and multiply them together. But it's not too bad, right? We just take 4, 3, 2, 1, 0, and the negative 2 goes 0, 1, 2, 3, 4. Then we take all those powers. Pascal's values in the front, 1, 4, 6, 4, 1. 3 to the 4th is 81. 3 cubed is 27. Times 4 is 108. Times negative 2 is negative 216. 6 times 9, because it's 3 squared, 54. Negative 2 squared is 4. Multiply those together. Gives you, I said 216, I wrote 126. I don't know why I did that. 216 w squared. 12 times, so 4 times 3 is 12, times negative 8 is negative 96w, and then plus 16 at the end. So that's how you expand something that looks like this. So often they don't ask you to expand the whole thing. They'll just ask for one coefficient. And in some ways, I think this is almost harder because you have to really think about what is going to give you this x cubed, y cubed. Because here, the first term will be x to the 6th. The next one will be x to the 6th times negative 2y. The next, sorry, x to the 5th times negative 2y. Next one will be x to the 4th times negative 2y squared, right? And we'll have Pascal's values in front of there. The 6th row, we've used this one before. It was 1, 6, 15, 20, 15, 6, 1. So that's our row. So now we're looking for x cubed, y cubed. So let's think about how that was created by this guy. So it had to be x cubed, but then it was negative 2y cubed. And then in front of it, we'll have 6 choose 3. So 6 choose 3, let's see, 0, 1, 2, 3, that's 20. So we have 20 x cubed, and then negative 2y cubed, that's going to give me negative 8y cubed, because I have to cube the y and the negative 2. So if I multiply negative 8 times 20, 8 times 2 is 16, so that's going to be negative 160 x cubed, y cubed. So my coefficient, negative 160. Let me go through that again, because this tends to trip people up a little bit. So x cubed, y cubed had to come from cubing the x and the negative 2y. So I'm cubing the x and the negative 2y. So this is in the middle of my expansion somewhere. I'm not writing out the whole expansion because I don't have to. But so I have x cubed times negative 2y cubed. So x cubed I can just leave alone. 6 choose 3 is going to be my Pascal's coefficient, so that comes to 20. Just get that from the 6th row of Pascal's triangle. And then negative 2 cubed is negative 8. So I multiply that by 20. It gives me my coefficient, which is negative 160. So the answer to this is negative 160, because they just want the coefficient. And that's all there is to it. Oh, I did have the triangle here. I was saying, I thought I put it somewhere. So we have 1, 6, 15, 20, 15, 6, 1. We see that. And we just wanted 6 choose 3, which is 20. So that's all I've got for you. I would suggest going through those examples again if you're still having some trouble understanding how it worked. But tomorrow we're going to have a review day, so you'll have a chance to work through these, and you can ask me questions about them, of course. And hopefully we'll be able to have a better understanding of this binomial theorem. We're also going to have a quiz coming up on Monday, so make sure that you take a look at this homework tonight. We'll talk about it more tomorrow, do a little bit of review of combinations and using binomial theorem, and then we're going to have a quiz on Monday, so look forward to that. I feel like I owe you guys some Throwback Thursdays, so I've got a few here. This is from my first communion. Would have been in, gosh, maybe 1992, maybe 93, somewhere in there. I was in first grade. This is the first suit I ever wore. Looks like I'm missing some teeth, too. This is my first code I ever wrote, and it was a very simple one. It just had a direct correlation from one symbol to a letter. And it looks like I wrote a message to my family, and then my mom wrote a message to me back. This is me in Scotland last year. It's where I went for spring break. Up next, this is called a Highland cattle. So the Highland cattle are famous for coming from Scotland. They have this shaggy mane and these long horns. So we were driving by one of these, and this was on the Isle of Skye in the very north of Scotland. And we said, well, we got to take a picture. So that's me with a Highland cow. This is also in Scotland. We climbed up to the top of a... Oh, no. That might be a lie. I think this... Nope, yep, this is in Scotland. This is on the top of Arthur's Seat in the city of Edinburgh. So Edinburgh is, you might call it the capital of Scotland. Scotland isn't a country. It's part of the UK. But Edinburgh is their biggest city, and it's where we flew into. And they have this incredible hike that gives you this great overview of the city. And that's all I've got for you today. And so if you still have some time and you want to do a crypto quip, you can pause the video here and write it out. Otherwise, give the worksheet and the, for sure, try the worksheet today. It's just an expansion. But if you want it for a little bit of a challenge, do the Lesson Master 10.3, and we'll talk through those tomorrow. Love you guys. That's why I'm here. Have an excellent day.